Well, I will begin giving a talk from over here, so excuse my walking around. Should I just say next slide, please, when we're changing? Okay.
Old school.
Okay, well, while I start talking over here, thank you all for coming. I'll just say next slide, please, and if you can run a clicker up, that would be good. The joys of giving live presentations. I'm glad to be back in person. So I want to talk about cookies. Next slide, please. Great. So if you were here in 2022, you probably remember Professor Craner gave a great talk on the subject of cookies. That one. Super interesting topic. Lots of really interesting design decisions. You can talk about dark patterns, longest paths, whether users understand what the accept and reject buttons are, what sort of preferences you should expose. Should you expose lots of choices, not a lot of choices? I can't really do better than point you to Professor Craner's talk from last year. There's plenty of other papers on this subject. Down to forward. Legend. Thank you very much. Also, thank you very much to the USENIX technical staff who have made this work very last minute. I want to talk about something that's not this. So I want to talk about, let's imagine you're me and you're working on a sort of infrastructure team at a big company. You've worked with a front-end team. Your front-end team has done user research. They've thought about dark patterns. They've built a cookie consent flow that's usable and understandable to users. It's perfect in every regard. And they hook up a JavaScript on-click handler to the decline all cookies button, and they say, hey, Katriel, could you fill that bit in, please? I think my takeaway here is there's actually lots of really interesting questions that happen in that bit. And so for the next 10 minutes or so, I would like to talk about that bit of what you do. So what do? Well, you probably want to record the choice that the user made somewhere. And the simplest possible choice you could do is stick their result in a cookie. No joke, this is the most common thing that people do with a cookie consent. We do this on a bunch of the smaller Facebook websites. It's pretty simple. It's easy to understand. It has a couple of disadvantages. I'll get to that as well. But this is a pretty reasonable thing to do. The more high-powered or complicated option is to send it up to the server somewhere. So you have some endpoint that records cookie consent choices. You have some identifier for the current session or device or browser or user. And you send this user, the current user has marked themselves for optional cookies false. Both of these are good answers. There's no right answer. Storing it locally is simple and easy. It makes it a little bit harder to measure your overall statistics, like how many users are accepting or declining cookies. You often want to know this if you're rolling out changes to understand, like, have you built something usable? Storing it on the server, you have to have server-side costs. Every browser session will hit this, so this actually tends to be a pretty hot code path. But I think the most important choice here is that if you're storing server-side, you can unify the choices across different accounts. And this, I wouldn't go so far as to say it's a dark pattern, but it's really annoying if you go to a website on Chrome and it asks you something about declining cookies, and you go to the same website in Firefox and you're still logged in, and it asks you the same thing. So if you store the cookie consent options against the account level, which you can do by linking to the account on the server, at least you can then unify that, and so you don't have to ask the user the same questions over and over. But I think that's the easy part. The hard part is, well, if you have some choice, like decline optional cookies, you should probably do something different on the server if the user declines optional cookies. Right? That's the point of having a choice. And I'm an engineer. I know what code I would write if somebody told me that. I would Control F or grep through my code base, and I'd find all the places we called set cookie, and I'd go and ask my privacy team, like, hey, Tarek, is this an optional cookie? And you'd be like, yes, that one's optional. I wrap it in an if statement. This is just like the obvious intuitive thing to do. This is bad, right? There's a couple reasons it's bad. Maybe it's already like sprung out to you. The biggest reason it's bad is that if you do this, you're relying on your product developers, who really would prefer not to have to think about cookies all the time, to remember, should I add an if statement while I'm updating the marketing site to include a YouTube embed plugin? And it means they have to understand what counts as optional, what counts as essential, whatever. So this is Fragile. I want to talk about how we did it at Meta, which I guess the short summary is we try and make the infrastructure handle this. I should introduce myself. Hi, I'm Katriel. I'm an engineer in Meta's privacy team. I've worked on access, deletion, and I've been lucky enough to work with the team that built Meta's cookie banner. So over the last few years, if you went to facebook.com 5 years ago, you would see a little banner at the bottom that said, by sneezing, you accept cookies. We don't have that anymore. We have what I think is actually a pretty good cookie banner, or at least as good as a cookie banner can be, which is a low bar. But we have an API in particular internally that does not have all these pitfalls of if statements and making developers remember things. I put it at the bottom of the slides. So yay. This is what our cookies reading and writing API looks like. I'll move it up. OK, a couple cool things about this API that I want to call out. So the first thing is, well, it's very simple, right? Like, there's not a lot of if statements. There's not a lot of random strings or configuration options. If you want to read the foo cookie, you call read with the foo cookie. And in fact, one of the nice things about owning your whole server-side code base is that we enforce that you must use this API. So if a developer, Facebook runs on PHP. If you're familiar with PHP, you usually get the cookie from $_cookie. We actually own the initialization stack of the web server, and so we strip out the cookie values from that. If you try and read cookies out of $_cookie, you will get an empty string. The only way to get them is through this API. This is great. It means you no longer have to grep for random $_cookies thing in your code base. Syntactically, like every call site of this API is where cookies are read. A few other things I want to call out. We don't take arbitrary strings. We take an enum value. So there's actually an enum. It's called cookie schema prod.php. And the only way to read and write a cookie is to pass it an enum value that's in that enum. This is super useful. It turns out, if you've worked on cookies for a while, by far the most common question that your lawyers ask you is, what cookies are set on oculus.com? In 2020, what cookies were set on facebook.com? And we can just answer this now, right? Because all we do is we go to cookieschema.prod, and I read through the list of every enum value, and I say, like, cookie.foo, great, the foo cookie was set. And it has the name of the cookie, and it has the other configuration options. So this alone is like a super useful thing to introspect your code base. And it means you no longer have to grep around to try and find what people are doing. I talked about having to add if statements everywhere. You don't have to add if statements everywhere now. Nice thing about this is you mark on the schema once. So when you're creating a cookie, you'll probably go through a privacy review. You'll be talking to your lawyers and your privacy engineers and so on. And at that point, you mark this cookie as optional. Great thing about this, the API can now handle all the rest for it. So we know internally in the Cookie Manager API, the current user who's logged in is Katriel, and he has not consented to optional cookies. And so if somebody tries to read or write an optional cookie, the API will just say, yeah, no, you can't do that. And it will just return null. Great. We never have to get developers to remember, do you have to check for consent or not anymore? Super useful. There's various other configuration options you can also put in the schema. You can put the TTLs. This turned out handy. I'll talk about that in a second. If you know HTTP only or secure flags on a cookie, we set those on the schema as well. We're working on CSRF protection to get CSRF cross-site request forgery protection against cookie writes. We can tell how well the rollout is going because we mark it on the schema. And then I can, at a glance, scroll through the cookie schema prod.php file and see, these 8 cookies don't have it set. OK, cookie schemas are great. They're safe by default. Developers don't have to remember to check anything. The list is statically available. If you want to know what cookies you have, you look at the schema, and it's there. We actually have an intern tool, so you don't even have to read code. I can literally send our lawyers to the intern tool to read this. And you can make changes centrally. You might all remember that Chrome in August 2022 capped TTLs of all cookies to 400 days. We wanted to set our internal TTLs to 400 days as well to match that. It's a bit silly if Chrome is capping to 400 days and we're asking 800. In order to do that rollout, we just looked at the schema and we said, here are the 8 cookies that have longer TTLs. We'll change them one by one. Great, cookie schemas. I want to talk in the last, 3 minutes about third-party cookies. So you'll remember a first-party cookie is you go to facebook.com, and the cookie is set for facebook.com. So the cookies have a domain, and the domain equals what you see in the URL bar. But you can have a third-party cookie, right? If you embed a tracking pixel from, I will politically say, example.com, if you embed a tracking pixel from example.com, that's running somebody else's server code, and that might read or write cookies. And if you stick that script tag in facebook.com, then it will set read or write third-party cookies on Facebook. And you probably want some controls over that, right? On Facebook, we have a other companies' trackers control, it's called. You can opt out of it. If you opt out of it, we don't set other companies' trackers unless blah, 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 policy, blah, 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 star. But you want some way to enforce this. And this is a little harder to enforce at first because we don't control example.com. And we had what I thought was a neat internal insight until I realized that loads of other people had already had that. And I think in 2 talks, you'll hear a bunch more about this as well. But the neat insight is that you can use content security policy headers to sort this for you. So a content security policy header is a browser tool that instructs the browser what domains it can connect to or load data from. And so if you set a content security policy header of default source self, that means if you try and embed a script tag like that, the browser will just decline it. You'll get an error message in the browser saying that's not a valid embed. This is great because that means we, the Facebook server, can now serve a content security policy header that enumerates exactly which third parties are allowed to be embedded. And we can control that per request. What that means is if I have opted out of optional cookies or of third-party embeds on facebook.com, we can serve a content security policy header that will block them. And you can actually see this today. If you're in the EU and you toggle the other companies' trackers toggle, and you look in the web request, you will see a very long and specific content security policy header showing exactly which third parties we're able to embed. And this also means you can put it in a schema, exactly the same as cookies. We have a big file with an internal code name.php, and it has a list of here's the third parties, here's their domain, here's the name. We have whether they're optional. We have that one's still being rolled out. It's a bit decentralized right now. We have various other tags as well on the schema. OK, this is pretty cool. The CSP has a bunch of interesting challenges we run into along the way. And I have 1 minute, so I'm not going to talk about them in great detail. But grab me afterwards, I'll be here, and ask me about them. 3 that I wanted to call out. CSP is per domain. So Chrome doesn't know that facebook.com and fbcdn.net, which is our CDN, are in fact the same thing. And so if you serve a default source self policy on facebook.com, you'll break all the images on the site. Ask me how I know that. So we actually have to have a notion for every domain we own of which domains is this domain first party for. So like fbcdn is first party for facebook.com. That means if you request the specific no optional third parties CSP, we have to include in it fbcdn.net so that your images work, because that's first party. There's a whole lot of edge cases here, especially when you own lots of websites that are, it's unclear whether they should be first party or third party, and this is a somewhat hot topic on the web right now. Second, some people want star embeds. A fact I learned about the podcast ecosystem is that podcast creators expect to host their own content and have it embedded. So if you're building a podcast player, you have to be able to host content from anywhere on the internet, wherever some rando is hosting their podcast from. And so that means you need a star in your content security policy because you don't know what you're embedding from. But putting a star in your content security policy kind of disables a bunch of the protections here, and so you need to build safeguards around that. And third, and I think this is maybe the most interesting technically one, if you're familiar with how React and like full-page web apps work, React does not do a page transition when you change page. It does some magical JavaScript stuff to make it look like, to make very fast native transitions that are not reloading the page. But content security policy is a browser thing, and browsers understand page reloads. That means as you're navigating around a full-page React app like facebook.com, you're not changing your content security policy. And so we actually had to build some stuff into our React router that said, if you're navigating to the following controller, don't do a fast reload. Actually do a full page reload so that you get the new content security policy header. OK, lots of complications. They're not blocking. We made all of them work, but it was super interesting technically actually solving some of this stuff. So what do I want you to take away? Cookie infra is interesting. The front end is interesting, but also what you plug the front end to on your server. A whole bunch of technical problems I didn't really know about until I worked on them. Schemas are great. I think if you've watched a bunch of the Facebook talks at PEPR over the last few years, they're really a little bit the same, which is they're all, hey, we built this schema, and it's amazing, and you should do schemas. And I continue to hold that view. Schemas are great. If you have this big static schema in code of all your cookies, it unblocks a whole bunch of really interesting stuff. And this works for third-party cookies, too. You can use content security policy, hook that into an internal schema, and you can have governance over your third-party cookies as well. And I think you'll hear a bunch of that in 2 talks' time. Great. I'm done. Thank you.